Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. Today in this session we are going to learn about salt hydrolysis. Let's start the session. Salt hydrolysis. So, when some salts are dissolved in water, some salts results in acidic solution, some salts results in basic solution, and some salts result in neutral solution. Okay. We are speaking about which type of salts on dissolving in water that they undergo hydrolysis process and results into whether acidic solution or basic solution or neutral solution. Let's see. So salt hydrolysis is here, it is a reversible reaction. That means salt reacts with water to form acid and base. On looking at what you are finding, we are finding that it is reverse to that of neutralization reaction. It is reverse to that of a neutralization reaction. In neutralization reaction, according to Arrhenius, we have studied that acid react with base to form salt and water. Here salt reacting with water, that is the process called as hydrolysis, forming acid and base. The hydrolysis reaction is reversible reaction. Yes, it is reversible reaction. It has both forward direction reaction and backward direction reaction. The hydrolysis process is reverse reaction of neutralization. Yes, you are finding that it is reverse of neutralization reaction. And here it is a reversible reaction. Reversible reaction means, what is the destiny of this reversible reaction? After a certain time, the reaction attains equilibrium. When it attains equilibrium, what do we write? We write equilibrium constant. So equilibrium constant is written for whom? It is written for reversible reaction which is at equilibrium. So let us write equilibrium constant. So equilibrium constant K, Kc I am writing. Equilibrium constant is equal to acid concentration into base concentration by, what do we write? Salt concentration into H2O concentration. And we know that concentration of water is 55.56 molar, and its concentration is very high, and during this reaction this concentration of water does not change. So I can write it as K equilibrium into concentration of water is equal to acid concentration into water base concentration by salt concentration, right? So K equilibrium into K concentration of water is written as KH. Okay, so what is this KH? Acid concentration into base concentration by, what do we write? Salt concentration. Do you understand? So what is this KH called? So this KH is equilibrium constant in the process of hydrolysis of salt. So it is called as what? Hydrolysis constant. What is this called as a hydrolysis constant? So you are finding here hydrolysis constant. It's represented by water KH. Okay. Now the fraction of total salt which is hydrolyzed at equilibrium is called as degree of hydrolysis. We have studied before degree of dissociation we have studied, which is what is degree of dissociation alpha. We have studied degree of dissociation, which is called as alpha, right? What is degree of dissociation alpha? Number of moles of a substance, whatever the substance you take, substance dissociated. See, some substance is, for example, some substance is dissolved in water. In that, some of the moles got dissociated. Some of the moles got dissociated. That is called as here number of moles of substance dissociated by total number of moles. Okay, this is the definition for, this is the mathematical representation for what, for whom? Alpha. Alpha is it. In the same way, as we are discussing the process of hydrolysis, we don't use the word called as degree of dissociation. We use the word called as degree of hydrolysis. What is this H called as a degree of hydrolysis? What is this H? Number of moles of salt hydrolyzed. That means here, for example, let me take, what is this? This contain water. What does this contain? Water. Into this I am adding some 2 moles of salt. What I am adding? 2 moles of salt into it. Among the 2 moles, let me take only 0.1 mole salt hydrolyzed. Hydrolyzed means already I have discussed to you what is meant by hydrolysis. Reaction of salt with water. It's called as hydrolysis. Only 0.1 mole salt is hydrolyzed. The complete salt is not hydrolyzed. Then what do you write? H is equal to how many moles hydrolyzed? 0.1 mole hydrolyzed by total number of moles. How many moles you have kept into this water? 2 moles. Then what do you get? That is equal to 1 by 2 into 10 power minus 1. This can be written as 10 into 10 power minus 2 by 2, that is equal to 5 into 10 power minus 2. Understood? So what is this called as what? H is called as degree of hydrolysis. In chemical equilibrium, we have studied K equilibrium, equilibrium constant, Kc, Kp. As this process is hydrolysis process, we are studying it as hydrolysis constant. In the same way, we have studied alpha as degree of dissociation. Degree of dissociation. As this process is hydrolysis process, we are studying it as a degree of hydrolysis. Degree of hydrolysis. Understood? What is KH? Hydrolysis constant. What is H? Small h? It is degree of hydrolysis. So let us see a salt. First salt. Okay. Hydrolysis of salts from strong bases and strong acid. Strong acid and a strong base. So for example, let us take NaCl. How is NaCl formed? How is NaCl formed? Let us take NaOH. When react with HCl, what is formed? NaCl plus H2O. So this is salt. What? This is salt. Salt from whom? strong acid, strong base reacting with the strong acid. When strong acid react with strong base, the salt is formed. See, here we are speaking salts of strong bases and strong acid. Salt from strong acid and strong base. Okay. Now you see here this salt NaCl. What is that? Na plus Cl minus, right? Where is this Na plus from? This Na plus is from strong base. Na plus is from strong base. So it will be weak. Who will be weak? Na plus will be weak. Why it is weak part? Because it is from strong base. Cl minus is from whom? HCl. What is HCl? HCl is strong acid. Again it will be weak. So as the cation and anion of the salt are weak, why they are weak? Because they are from strong acid and strong base. So they are weak. Okay. Now here Na plus, let us take Na plus, stable, highly stable. It has got octet configuration. Cl minus, it also has got octet configuration and it is also highly stable. As they are stable, they don't react. Weak here represent. Do they react with water? Are they unstable? No, they are highly stable. Stability here represents in the terms of its condition reacting with water. Do they react with water? No. Why don't they react? Because they are weak. They are highly stable. So they don't react with water. So when you are reacting it with water, there is no reaction. If any of the path, either cation or anion, are strong, then that stronger path will react with water. Are you getting this? So as the both cation and anion are from strong acid and strong base, these are found to be weak. As they are weak, they don't react with water. When they don't react with water, already we know that just they dissolve, that's it. What happens? Na plus and Cl minus, just they dissolve, they don't react. And we know that the nature of pure water is neutral and its pH is equal to 7. pH is equal to 7. So when you dissolve this type of salt, as they don't react with water, as there will be no net H plus and OH minus release, the nature of the solution will be neutral and the pH of the solution will be 7. Right? Simple thing. So what did you understand? The salt is formed from strong acid and strong base. Then if you dissolve it in water, the solution will be neutral and the pH of the solution will be 7. Simple thing. Understood? Okay. So this type of salts do not undergo hydrolysis. They don't undergo hydrolysis. The aqueous solution of this salt is neutral and the pH is equal to 7. So first point, what you need to remember, if the salt is from strong acid and strong base, then its aqueous solution will be neutral. In the same way, let us take a KNO3. So how is this KNO3 formed? From where it is this KNO3 formed? So KOH, when it reacts with the HNO3, gives rise to KNO3 plus H2O. Again, what is this base? Strong base, strong acid, salt, right? Again, in the same way, Na2SO4, KiCSCl, KCl, Na2SO4. Let us take NaOH reacting with the H2SO4 gives rise to Na2SO4 plus 2H2O. Again, this is strong base, strong acid, right? In the same way, let us take Ki. Ki for Ki, KOH plus Hi gives Ki plus H2O. Strong base reacting with strong acid to form salt. In the same way, CSCl, CSOH reacting with HCl to give you CSCl plus H2O. This is again strong base reacting with strong acid. This is salt, salt of strong base and strong acid. The same way, if you see KCl, KOH plus HCl reacting to give you KCl plus H2O. Okay, strong base, strong acid, salt. Okay, so if the salt is formed from strong acid and strong base, and if it is dissolved in water, it just dissolves, it does not react with water, and that's aqueous solution will be neutral in nature. The pH of the solution will be 7. For a neutral solution, the pH is equal to 7, right? So the next one is this. Here is another salt. Hydrolysis of salts of strong acid and weak base. What is that? Strong acid and weak base. So very famous one is NH4Cl. NH4Cl. So let us take NH4Cl. If you consider this NH4Cl, it is formed from NH4OH and HCl gives you NH4Cl plus H2. What is NH4OH? Weak base. It is this weak base, and it is strong acid. Strong acid. This is salt, right? So which type of salts we are speaking about? We are speaking about the salts of strong acid. Yes, strong acid. We are seeing here strong acid and weak base. So weak base. Now this salt, let us take this salt. See, NH4 plus Cl minus. So where is it from? NH4 plus cation is from where? It is from weak base. Are you finding it? It is from weak base. So automatically this NH4 will be strong. And where is the Cl minus from? The Cl minus is from HCl. It is from strong acid. So automatically it will be weak. Now among this cation and anion, one of the part is strong. What part is strong? Cation part is strong. NH4 plus is strong. Why it is strong? It is from weak base. Okay, so you need to remember in this way, as NH4 plus is from NH4OH and NH4OH is weak base, that part will be strong, and the part of this salt which is strong will react with water. Are you getting this? The part of the salt which is strong will react with water. Now you can find here NH4 plus reacting with water to give you NH4OH and H plus. Who is reacting? Cation is reacting. Who is reacting? Cation is reacting. So this hydrolysis is also called as what? Cationic hydrolysis. What do we mention? Cationic hydrolysis. Why do we call it as cationic hydrolysis? Because the cation is reacting, the cation of the salt is reacting with water, resulting into acidic solution. Resulting into acidic solution. H plus is released. As H plus is released, then the nature of the resulting solution will be acidic. So why this hydrolysis of salt? Does hydrolysis occurs here? Yes, occurs here. Which part of the salt react with water? Cation part will react with water. That is the reason why it is called as cationic hydrolysis. So this cationic hydrolysis results in what nature of the solution? It results in acidic nature of the solution, because when cation react with water, H plus is released. Strong acid is released. Strong acid is released. That is the reason why this hydrolysis results in acidic solution. In the same way, let us see other salts. There are other salts, ZnSO4. Okay, ZnSO4. So ZnOH taken twice, when react with H2SO4, gives rise to ZnSO4 plus H2O. What is this? Weak base and strong acid. Weak base and strong acid. This is salt. Another way also you can remember this. How to remember this? Among these acid and base, which is stronger? Acid is stronger. So the nature of the hydrolysis, the nature of the solution due to this hydrolysis is acidic. Among the acid and base, which is stronger? Acid is stronger. When acid is stronger, that salt, when it undergoes hydrolysis, it results in acidic nature. So simple way of remembering is that which is stronger, let us see. Whether acid is stronger or whether base is stronger. Acid is stronger. So the nature of the solution will be acidic. If base is stronger among these two, the nature of the solution will be basic. In that way. Understood? Right? So let us go with aluminium nitrate. Aluminium nitrate. AlOH taken thrice, when react with HNO3, gives you AlNO3 taken thrice plus H2O. This is again a weak base, strong acid, salt. So strong acid. So well, aluminium nitrate undergoes hydrolysis, the resulting solution will be acidic in nature because it is strong acid. The salt is formed from strong acid. Right? In the same way, let us go with FeSO4. FeOH taken twice, when react with H2SO4, gives rise to FeSO4 plus 2H2. So weak base, strong acid, and salt is. In the same way, MgCl2, MgOH taken twice, react with HCl to give you MgCl2 plus 2H2. Right? Weak base. What is this? Strong acid, salt. In that same way, let us see the other one. Silver hydroxide reacting with HNO3 gives rise to silver nitrate plus H2O. Weak base reacting with strong acid gives salt and water. Okay, understood? So all these salts are from strong acid and weak base. We are taking an example. What is that example? NH4Cl salt is taken as an example. Is a salt of weak base NH4OH and a strong acid HCl. Already we have discussed. After hydrolysis, the resulting solution will be acidic due to presence of strong acid HCl. What is happening here? NH4Cl, the salt is from strong acid and weak base, reacting with water to give you water, NH4OH, weak base, and a strong acid. As this acid is strong and this is weak base, as this acid is strong, the resulting solution will be acidic. The resulting solution will be acidic. If it is acidic, the pH of the solution will be whether equal to 7 or greater than 7 or less than 7. It will be less than 7. So in the form of ions we are speaking about. See, NH4 plus, it contains water, NH4 plus Cl minus reacting with water to give you NH4OH plus H plus Cl minus. Okay. So Cl. So overall reaction will be what? NH4 plus. Actually, who is reacting? Who is reacting? NH4 plus reacts. So NH4 plus is reacting with water to give you NH4OH plus H plus. So due to this release of H plus into the solution, it is acidic. Okay. The nature of the solution will be acidic and the pH of the solution will be less than 7. Understood? Right. Let us see here the relation between KH, KB and KW. Here we are speaking about the salt from weak base and strong acid. Weak base and strong acid. So we are taking that weak base. So for this weak base, NH4OH dissolves into NH4 plus OH minus. When it is weak base, we can write, already we have studied that Kb we can equilibrium constant for a base. Equilibrium constant of a base. What you can write? NH4 plus into OH minus by what? NH4OH. This one. We are deriving the relation between whom? KH, hydrolysis constant, Kb and Kw here. Right? Now let us see this. H2O, when H2O dissociates into H plus and OH minus. For this, what do we write? We write a ionic product of water. So what is ionic product of water? Ionic product of water is written as H plus and OH minus. H plus into OH minus. Already we have studied about what is meant by ionic product of water and all those. And let us speak about KH for this reaction. For this reaction, what will be KH? Are you finding this reaction? This reaction? NH4 plus reacting with water gives you NH4OH H plus. What will be KH? KH is NH4OH into H plus ion concentration by, right, NH4 plus ion concentration. Okay. Now let us divide, see, Let it be, what is the said? Let it be A, let it be B reaction. So divide B by A. So what is B? Kw by, what is that? Kb. So Kw is H plus ion concentration into OH minus ion concentration by, and Kb. What is Kb? This is Kb. NH4 plus ion concentration into OH minus ion concentration divided by NH4OH. If it is denominator, if you move on, it comes into numerator. NH4OH comes. Now you see, cancel OH minus OH minus. Then what did you get? Kw by Kb is equal to H plus ion concentration into NH4OH concentration by NH4 plus concentration. Look into that. What is KH here? You can find KH. KH and these are same. What is KH? You have written it is equal to NH4OH concentration into H plus ion concentration by NH4 plus concentration. Kw by Kb also you got the same. What did you get? NH4OH concentration into H plus ion concentration by NH4 plus concentration. Are you getting this? So I can write it as Kw by Kb is equal to KH. Kw by Kb is equal to KH. So for this salt from weak base and strong acid, Kw by Kb is equal to KH. The salt is from weak base and strong acid. Weak base. So you, how to remember this? And the denominator you should have Kb. When, for whom do you write Kb? Weak base. In the salt, whether weak base is involved or strong base is involved, weak base is involved. So we are writing Kb here. How to remember that? So Kw by Kb is equal to KH. Right? We come across through such type of formulae. We also come across through Kw by Ka. When do we write Ka? For a weak acid. So when weak acid and strong base are involved, we write Kw by Ka. But here in the salt, as weak base is involved, we write here Kb. Did we get Kb? Yes, we got Kb. Kw by Kb is equal to Kh. Understood? See, Kw by Kb is equal to Kh. Let's move to the next part. So now only we have seen Kw by Kb is equal to Kh. And let us see degree of hydrolysis. What is this? Degree of hydrolysis. Coming to the degree of hydrolysis, so we know, now we understood that NH4 plus is reacting with water to give you NH4 plus and NH4OH plus H plus ion concept. NH4OH and so this is the NH4OH plus H plus ion concept. Right? At time t is equal to 0. What is that? Time t is equal to 0. Let the concentration of NH4 plus be C. And anyway, water concentration of water anyway, we know that it is 55.56 molar. As it is constant, we don't consider this water. It is simple water solvent. And its concentration does not change much because its concentration is very high. So we don't consider here it, right? And its concentration is 0, its concentration is 0. As it is reversible reaction, both forward and backward reaction occurs, and at equilibrium, C alpha be the degree of dissociation, C alpha be the number of moles dissociated. C alpha be the number of moles dissociated. And from the equation, stoichiometric equation, we can say that, what we can say, 1 mole of NH4 plus gives you 1 mole of NH4OH and 1 mole of H plus. So C alpha moles on dissociation gives you C alpha moles of NH4OH, and here we don't use alpha. What do we use? We use H instead, because it is the process of hydrolysis. As it is the process of hydrolysis, we use a degree of hydrolysis, CH and CH and CH, because 1 mole gives you 1 mole plus 1 mole. If CH moles dissociate, CH moles of NH4OH is formed and CH moles of H plus is formed. And at equilibrium, we know initially what is the number of mole, what is the concentration of NH4 plus. C is the concentration. At equilibrium, what will be the concentration remained? What will be C minus CH? Initially C, dissociated CH, remained C minus CH. So then what do you write? KH is equal to NH4OH into H plus ion concentration by NH4 plus constant, right? Then what you can write? So KH is equal to NH4 plus concentration is NH4OH is CH into H plus ion concentration is also CH by NH4 is C minus CH, which is equal to C square H square by C into 1 minus H. C gets cancelled, then you get H square by 1 minus H. Okay, so if the degree of hydrolysis is very less, okay, so KH will be written as KH will be written as CH square. When H is very much less than 1, that means degree of hydrolysis is very less. Degree of hydrolysis is very less. That means 1 minus H will be almost equal to 1. When 1 minus H is almost equal to 1, then we get KH is equal to CH square. Then what do you get? H is equal to KH by C. H square is equal to. Then H is equal to what do you get? KH by C. Are you getting this? H is equal to KH by C. Okay, so this formula is important. And in the previous page, we have studied that what did we study? We have studied that KW by KB is equal to KH. Did we study? Yes, we have studied. Then what will be H? Substitute here root KH is equal to what? KW by KB by C. See, instead of KH, what we are writing? KW by KB. Okay, so I can write it as H is equal to root KW by KB into C. Okay. So what is H now? Degree of hydrolysis KW by KB into C. And in this hydrolysis, we have studied that H plus ion concentration is equal to CH. H plus ion concentration is equal to what? CH. So let us take that. H plus ion concentration is equal to C into H. Now only we have studied that H plus ion concentration is equal to C into H is equal to root Kw by Kb into C. That is equal to root C into, right? I can write it as root Kw by Kb into C. So root C gets cancelled. Then what do you get? Kw into C by Kb, right? H plus ion concentration. H plus ion concentration is equal to what? Root Kw into C by Kb. Understood? Now we are going to calculate the pH. What we are going to calculate? pH. So we know that pH, calculating pH is equal to minus log H plus ion concentration. Minus log H plus ion concentration, that is equal to minus log, right, Kw into C by Kb whole power 1 by 2. Okay. Then what do you get on calculating this? Or the other way also you can calculate. For the purpose of understanding, we can make it like this. We can make it like this. So what is that? H plus ion concentration is equal to H plus ion concentration is equal to what did we write? Kw into C by Kb whole power 1. Let me multiply logarithm on both sides. Log H plus is equal to log Kw into C by Kb power 1 by 2. Right? Then what do you write? Log A power x is equal to x log A. So I can write it as half log Kw into C by K. Right? Can I write it? Which is equal to log A into B is equal to log A plus log B. And log A by B is equal to log A minus log B. So half into log Kw into C minus log Kb. Right? I can write. Then what I can write? I can write it as half into log Kw plus log C minus log Kb. Okay, what is all this? Log H plus ion concept. Log H plus ion concept. Now I am multiplying minus on both sides. If I multiply minus on both sides, then what do I get? Minus log H plus ion concentration is equal to minus, or let me multiply half into minus log Kw minus log C minus of minus plus log Kb, right? So minus log H plus ion concentration is equal to pH. pH is equal to half minus log Kw is equal to pKw plus log Kb is equal to minus pKb minus log C, right? Then that is equal to, so pH is equal to, I can write half pKw minus half pKb plus log C. Can I write this? I can write it in this way. Half into pKb, half into log C. So we have to remember that here some things. What are those? First thing is pH is equal to, we know that it is minus log H plus pKw is equal to minus log Kw, pKa is equal to minus log Ka, pKb is equal to minus log Kb, pOH is equal to minus log OH minus N. In these things we have to know. From these things we have written here. See, log Kb is here. So log Kb is equal, minus log Kb is equal to pKb. Log Kb will be equal to minus pKb. Log Kb will be equal to minus pKb. And we know that pKw is equal to pH plus pOH, which is equal to 14 at 25 degrees centigrade. 25 degrees centigrade. So then what do you get? pH is equal to, what I can write? pH is equal to half into 14 minus half into pKb plus log C. Half into 14 gives you 7. So directly I can write here it is equal to 7 minus half pKb plus log C. Here you can find it easily. Are you finding this? Finding this? pH is equal to 7 minus half pKb minus half log C. So if you write it in detail, what you write? 7 minus half pKb minus half log C. So this is the formula. Understood? Understood? Right? So what is the nature of the solution? Here, what is the nature of the solution? The nature of the solution is acidic. If the nature of the solution is acidic, then what will be its pH? Its pH will be automatically less than 7. See here, pH is equal to 7 minus something. 7 minus something will give you less than 7. 7 minus something give you what? Less than 7. Have you got it? Have you got it? pKb is written. Now we have seen the salt from strong acid and weak base. Base is weak. So for whom you write pKb? For weak base. So Kb or pKb will be given in the question, and the concentration of that solution will be given, so that you can calculate the pH of salt from weak acid and from strong acid and weak base. Strong acid and weak base. Understood? So this is about the hydrolysis of, we have seen hydrolysis of two salts. One is salt from strong acid and strong base. Another is hydrolysis of salt from strong acid and weak base. Let us wind up this lecture, and in the next lecture we shall discuss the hydrolysis of salt from strong base and weak acid, and the salt from weak acid and weak base. Thanks for watching. Let's meet in the next session.